So in this video, we're going to take what we know about both angular speed and linear speed and apply it in two different applications. This example right here is talking about the speed of a bicycle. We know that the bicycle tires have a radius of 13 inches and that they are rotating or turning at a rate of 215 revolutions per minute. So I want to ultimately find out how fast the bicycle is traveling, and I want to know in miles per hour. It's a lot of information to take in at the beginning, so let's just take a second and again write down what it is that we know. I know that the radius is given to me as 13 inches. I know that the wheels are turning at a rate of 215 revolutions per minute. That's the angular speed, right? That's how fast its theta is changing. 215 revolutions per minute. And I'm ultimately trying to find how fast it's traveling. That's how fast it travels in a straight line in miles per hour. Miles per hour. So I wrote all of that down so that we can kind of start to think about a couple of things. I know that velocity is given, the formula for velocity is the radius times the angular speed. But before I can apply it to this, before I can apply what I know to this formula, I've got to do some stuff up here. First off, with the angular speed. Remember, angular speed needs to be in radians. This is actually given in revolutions. So what I need to do is I need to take it out of revolutions and put it into radians. So in my head, I need to start thinking, okay, if one revolution around a circle is 2 pi, one revolution is 2 pi, then 215 revolutions would be 2 pi times 215. Okay? So in other words, when I'm given an angular speed in revolutions, I'm just going to multiply that number by 2 pi. So let's kind of sneak that number in here. Okay? Move that over. So I know that 215 times 2 pi is actually going to give me, when I do it on the calculator, 430 pi radians per minute. Okay, radians per minute. So we've changed the angular speed from revolutions per minute into radians per minute. And I can now apply it using the formula down here. Something that we're going to need to do though, and we can do this, well, let's go ahead and use the formula first. So if I know that volume is the radius, which is 13 inches, times the angular speed of 430 pi over radian per minute, okay? And I didn't state this, let me state it now. I want an approximate answer to 2 decimal places. Okay, that is important information because when I plug this into my calculator, I'm actually going to use the pi button on my calculator and get a decimal value for this entire answer. So when I do that, 13 times 430 times pi, I end up with 17,561.50 inches per minute. Inches per minute. Now I wrote it like this because they asked me to find it in miles per hour. So we have to go back and we have to convert inches into miles and minutes into hours. Okay, that's not going to be that hard. It's actually a series of unit conversions that you probably remember from doing chemistry. We also have the conversion up here that they gave us, that there are 5,280 feet in 1 mile. Okay, so I can go from inches to feet to miles in a series of conversions. And then I'm also going to change from minutes into hours. So let's move this down, and I'm going to come over here, and I'm going to start with my velocity that I found, 17,561.5 inches over 1 minute, and I write it as a fraction because that's how I'm going to start canceling things out. So I need the conversion that gets me out of inches and into feet. Hopefully you all remember that there are 12 inches in 1 foot. So because we can write it like this, my inches are going to cancel, leaving me in feet. The next conversion I've got says there's 5,280 feet in 1 mile. So feet are gone, and I'm left in miles. So remember, I need miles in the numerator, and that's where I'm at right now. With the unit, miles in the numerator, so far I'm doing this great. Okay, the next thing, let me change this. The next thing I'm going to multiply by, let me go back, hold on. We want 5,280 feet for 1 mile. Okay, so the next thing I'm going to convert is minutes into hours. So I know that there are 60 minutes in 1 hour. So minutes is gone over here. And so I'm going to check to make sure I've done this right. I'm left in miles per hour, which is what I needed right here. So as long as I go back and double check that my units are in the right position, miles in the numerator, hours in the denominator, now I'm ready to go ahead and multiply straight across and divide by the product of the denominator. Okay, so we do that and we get approximately 16.6 miles per hour. That's how fast the bicycle is traveling. Okay, so really the only thing about this particular problem, you want to make sure that when you're using angular speed, that you convert it into radians. Okay, we needed a rate, so it was radians per minute in this case. So to do that, we basically just multiplied the revolutions by 2 pi. And then because this particular problem was conversions, we had to convert from inches per minute ultimately into miles per hour. All right, let's look at the next one. This is the last example for this section. And it asks you to find the linear speed of a golf club. The linear speed of a golf club. So just reading through this quickly, we can see that it says, all right, the shoulder joint can rotate at 25 radians per second. So if a golfer's arm is straight and the distance from the shoulder to the club head is 5 feet, what is the linear speed of the club head? So just, I don't know, just to kind of help you visualize what's happening here. Here's my shoulder joint, here's my arm, and here is the club head all the way down here. So the club head is making some sort of rotation, okay? And it's rotating at a linear speed, right? It has a linear speed, and that's ultimately what we are trying to find. We are given that the rotation of the shoulder and ultimately the club, the rotation of this, which is the angular rotation, is 25 radians per second. And we know that the golfer's arm from the shoulder to the club head is 5 feet. So that's the radius. So we just use the formula for linear velocity, which says velocity is the radius times the angular speed, which would be 5 times 25. So the velocity is 125 feet per second. Okay, pretty straightforward. You have to identify which formula that you're using. Again, if you'll start by writing down the known amounts that are given in your information, then it helps you piece the puzzle together as to what it is you're finding. Okay, and that concludes that lesson on angular and linear speed.